Hi, my name is Abigail Kirchmer, and this is my assignment for Block 4 of ITM. For today's video, we'll be talking about all things data. Some of the information we cover today will be a little confusing, but bear with me, and hopefully I can explain it at a basic level for better understanding. For today's presentation, we'll be talking about data modeling, and then we'll move on to databases. There are numerous databases out there, but today we'll be focusing on relational databases and NoSQL. To begin our presentation today, we'll be talking about data modeling. Data modeling is the analysis of data objects that are used in a business or other context and the identification of the relationship among these data objects. It is the formalization and documentation of existing processes and events that occur during application, software design, and development. A data model can be thought of as a diagram or flowchart illustrating the relationship between data. To better understand data modeling, you should know why it's so important. Data modeling techniques and tools capture and translate complex system designs into the easily understood representations of data, flows, and processes, creating a blueprint for construction and/or re-engineering. These models allow people within the company to identify errors and make changes before any programming code has been written. Many models are often used to ensure no errors slip through. There's a lot we could talk about with regards to data model, but with a short time period, it is important that we talk about the two basic methodologies. These methodologies are bottoms-up models and top-down models. Bottoms-up models are also referred to as view integration models. They are also a re-engineering effort. Bottoms-up methods usually use existing data structure forms, fields on application screens, or reports. These applications are application-specific. From an enterprise perspective, they're usually thought of as being incomplete. Some feel that bottoms-up models do not promote data sharing. This is even more so true when they are built without reference to other parts of the company. Top-down models are somewhat of the opposite of bottom-up models. Top-down models are created in an abstract way by getting information from people who know the subject. It may not include all the entities for a logical model, but it can serve as a reference point or template. Sometimes models can even be a mixture of the two models we just discussed. It is truly up to the data needs and structure of an application. So in summary today, we discussed at a very basic level what data modeling is. To refresh your memory, data modeling is the analysis of data objects that are used in a business or other context and the identification of the relationships among those data objects. Data modeling is important because it allows for errors to be identified before the program code has been written. The two basic methodologies for data modeling are bottoms-up model and top-down model. Let's now jump into databases. As people have become more and more reliant on computers, the internet, smartphones, etc., there has been a serious increase in the use of data. The old framework of data management is no longer applicable and cannot hold up to the amount of data being used. Thankfully, new technologies have been developed to help us work with data at a massive scale. Today, we'll be talking about two databases that can do just that. These databases are relational databases and NoSQL. Relational databases are sometimes referred to as a traditional database. They have been the standard database used since the beginning of the internet. Data within the organized in a highly structured manner and follows the relational model. Although it has been the traditional database, relational databases seem to be declining. The database requires that the organization of the data be very neat, and that becomes extremely burdensome with huge amounts of data. The next database we'll be talking about, NoSQL, is a better solution for huge amounts of data. NoSQL is a database that has been developed to meet the demands of high quantities of data. NoSQL is far different from a relational database that allows for high-performance, agile processing of information at massive scales. NoSQL varies from the relational database in the fact that it is unstructured. This quality allows NoSQL to have speed and agility. NoSQL has distributed databases where unstructured data may be stored across multiple processing nodes, and often across multiple servers. NoSQL just requires that you add more hardware as more data storage is needed. Things like Google, Amazon, and the CIA use NoSQL. Data is just going to continue to grow as people rely more and more on the internet. Innovative approaches like NoSQL are absolutely necessary. Although relational databases have been an effective approach in the past, they're becoming somewhat obsolete. Innovative approaches are essential for companies and individuals to reach full potential. In review today, we talked about data modeling and databases. The world is becoming more and more reliant on the internet and data. It is important that you have a basic knowledge of these two subjects. Again, data modeling is the analysis of data objects that are used in a business or other context, and the identification of the relationships among those data objects. And the two databases we went over today were Relational Database and NoSQL. Thank you for listening. I hope you learned something today.